In this video, we will have a better look at the Eutectoid reaction. So, I told you in the previous lecture on the phase diagram of iron carbon that the Eutectoid reaction is the most important invariant reaction that we need to study. Okay, so, let us draw that once more. Here we have the Eutectoid reaction. So this is at 0.8 percentage and this is at 0.02 percentage. This is alpha, this is alpha plus gamma, and here you have gamma. You have gamma plus Fe3C, and here you have alpha plus Fe3C, right? This is 725 degrees Celsius, and this is 910 degree Celsius. So eutectic reaction, you have gamma is getting converted to, it is cooled at 725 degrees Celsius to alpha plus Fe3, that is alpha ferrite and cementite. Okay, so this gamma is a combination composition of 0.8 percentage, alpha is of 0.02 percentage, and cementite is 6.67 percentage. Okay, so just a reminder how to find the composition. This is by draw a tie line just below this. Okay, so this tie line here will give you the composition of Fe3C, and here the composition will give you here this intersection will give you C alpha or the composition of alpha. Okay. So in that way you can find the composition of alpha and cementite. Okay, so this so we have discussed this for a particular composition, that is C or is equal to 0.8 percentage. So the steel with 0.8 percentage carbon are called eutectoid steel. Okay, eutectoid steel. Okay, and this composition, if it is less than 0.8 percentage, we will call it hypoeutectoid steel. And if composition is greater than 0.8 percentage, we will call it hypereutectoid steel. And this is the difference. So let us look at the microstructure evolution. Microstructure evolution um, for a eutectoid steel. So um, this gamma, you know that it is solid. So that means this is a polycrystalline. So we have seen what it mean by polycrystalline. It has got many grains. This is a polycrystalline material. That means you have gamma here, gamma here, gamma. This gamma itself is a interstitial solid solution of carbon in FCC ion. So this FCC has got a different orientation. That is why you have different grades. So what happens during the eutectoid reaction? Okay. This gamma is get converted to a lamellar structure of, you can see here. So this is a lamellar structure of this hard region is called Fe3, that is cementite, and this white region is called alpha. Okay, alpha phase. That is gamma is getting converted to alpha, and that is alpha ferrite and cementite. That is a mixture of two phases. Okay, is the mixture of two phases or micro constituents. Okay, these are the micro constituents in eutectoid steel. So now let us look at the microstructure evolution. Evolution for a hypoeutectoid state. For a hypoeutectoid steel. That means a steel with composition less than 0.8 percentage of carbon. Okay, again you have here a polycrystalline material that is alpha, sorry, it is gamma, okay, gamma throughout. So what happens when it is converted to so let us look at the phase diagram here. So you can see that the reaction occurs like this. Okay, it is 1, and here if you take a point that is 2, and that is 3. That is, it is below 0.8%. You can see that there is an intermediate region that is the alpha plus gamma. Okay. So if you look at the microstructure, you can see that this forms like this. Okay. You have this gamma here. Okay. So this gamma will remain same. Okay. But small ones of alpha will start to form in the grain boundary. Okay. So let's see. Alpha will form in the grain boundaries. Okay, you can see here. Okay, these are the grain boundaries you can see, right? So you can these are alpha. Okay, so these you can call these as pro-eutectoid alpha. This is pro-eutectoid alpha ferrite. So pro-eutectoid alpha ferrite, right? And so after that, okay, once it crosses this point, okay, once it crosses this point, you can see that it is getting converted to, there is a eutectoid reaction occurring, and this gets converted to, the remaining part will get converted to the alpha plus cementite phase or eutectic reaction occurs. So this will be like this. So so here you have this alpha. Alpha will remain there, that is pro-eutectoid alpha ferrite. And in addition to that, you have this micro constituents. Okay, that's phases of alpha and cementite. It's alpha and cementite. So one more thing, this eutectic mixture, okay, this eutectic mixture that is okay, it's alpha plus ferrite, alpha plus cementite. This is called pear-like. Okay, this is called the pear-like. Okay, so I think so. This structure is called pear-like. That is a eutectic mixture of alpha and cementite. Okay, so this is the microstructure evolution. Now we will look at the microstructure evolution for a hyper eutectoid steel. This is the microstructure evolution. Microstructure evolution for a hyper eutectoid steel. For a hyper eutectoid steel. That means it will be this region. We can go that here. So this one from 1 to 3. You can see that this gamma is converted to gamma plus Fe3. See, then it is converted to alpha plus Fe3. So that is the hyper-eutectoid steel. So what will be the microstructure evolution? So first, you know that you have a alpha, sorry, gamma. iron. Okay, this is gamma, 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 and gamma. So it is first, you can see that it is moves from 1 to 2. It is getting converted to gamma and cementite. Okay, so that means this will be so cementite. See what happens. So this is gamma, gamma, gamma. In the green boundaries, you can find that small regions of cementite will start form. That is Fe3C. So it is draw some more gamma here. So, so it will form here. Okay. Small cementite starts to form, right? And finally, it's getting converted to is here it is C. Finally, you can see that you have this cementite in all these boundaries. So you have this cementite here, and then you see once it crosses the eutectoid temperature, this all these grain boundaries get becomes cementite, okay, and then remaining portion, so that will be converted to pearlite. So that is pearlite. So this remaining portion, that is remaining gamma, will convert it to pearlite. It's converted to pearlite, and this portion is the cementite. Okay, cementite or Fe3C. This is Fe3C. So this is the microstructure evolution for a hyper eutectoid steel.